So the second thing we're going to look at is an extra section after 11.6 on what's called the distance formula. Now, please don't get this confused with what we already think about when we say distance formula in algebra, and that is d equals RT. That is the distance formula when it relates to speed and time and rate and distance. We're not talking about that. What we're talking about is on a coordinate plane, the distance between 2 points. And so here's how this works. The first thing you need to be able to do on this is remember, how do I find the distance between 2 points on a number line? And so if my number line is like this, and I asked you how far apart are -3 and 12, hopefully most of you could just look at it and you know number lines and distance well enough to know that the answer is 15. But in a very formal way, you can always find the distance by saying it is 12 minus a -3. The point on the right minus the point on the left. And that will always give you the distance between those 2 points, 15. If you did it the other way, -3 minus 12, you just get the opposite. So you could also think about it as the absolute value of the difference of the coordinates, and then you always get the right value when you're trying to find the distance. The reason that matters for us is if we're trying to find the distance between 2 points on a plane, so let's say the point -3, 2, and 4, 6. Okay, and so if we want to find the distance between -3, 2, and 4, 6, we're trying to find the length of that. Well, right now, the only thing you guys have talked about, or we've talked about to find length, is the Pythagorean theorem. So we use that, and the way that we use it is by drawing in a right triangle. When we draw this right triangle in, what we realize is we get a horizontal number line and a vertical number line. The horizontal number line, the x value here is -3, and this is 4. For the vertical number line, this is 6, and this is 2, right? The y-coordinate for this bottom comes from this coordinate over here. The x-coordinate for the other one comes from that x-coordinate over there. So what in this right triangle, what is that length? It's going to be 4 minus a -3, which equals 7. This one is going to be 6 minus 2, which equals 4. So we're just going to do 7 squared plus 4 squared equals the distance squared. And so we get distance equals the square root of 65. In a more formal way, you could think about it as the distance equals the square root of, well, remember 7 squared was just 4 minus a -3 squared. And then 4 was just 6 minus 2 squared. And so this is what the distance formula is. And the way that we derive that distance formula is exactly how we just solved that problem, which is I take 2 points on the in the plane. I call one of them x1, x2, or y1. So that's kind of like point 1, right? The subscript 1 says, okay, this is the x-coordinate from the first point. This is the y-coordinate from the first point. And then this one we're going to call x2, y2. It doesn't matter the order that you do these, and I'll show you why in a second. And so if we want to find the distance between these 2 points, then we draw this right triangle. And we recognize, oh, wait a second, this is just x2 and this is x1, so this length is x2 minus x1. And this length is just going to be y2 minus y1. And so using the exact same idea we did before, we say, well, wait a second, the distance is just x2 minus x1 squared, this length, that's what that length is, plus y2 minus y1 squared, equals the distance squared. That's just from the Pythagorean theorem. We take the square root of both sides and we get the distance formula. So the distance formula is the distance between 2 points x2, y2 and x1, y1 is the square root of the quantity x2 minus x1 squared plus y2 minus y1 squared. Now, inside these parentheses, note the x2 and the y2, x2 and x1 and y2, y1, it doesn't matter the order you do it because you either get a positive or a negative value, but you're squaring it, and so it's going to be positive, and so you're going to get the same value whether you got a positive or a negative, as long as it's the same number, and they're just opposites of each other. And so you're going to get that same value, so it doesn't actually matter the order you put them in. You just have to make sure that you're subtracting them and not adding them. And so this is your distance formula. It can be used on any type of problem. What is the distance between -3, -6, and -1, 8? in a coordinate plane? Well, we just plug it directly into this formula. It doesn't matter which one's x1 and y1 and which is x2 and y2. They just have to be separated by x's and y's. And so if we call this x1, y1 and this x2, y2, then it's going to be the distance equals the square root of x2 minus x1. So it's going to be -1 minus a -3 squared plus y2 minus y1, which is 8 minus a -6 squared. And then because even these are both positive, so it doesn't matter, but even if you got negative values there and you squared them, they would be positive. So 2 squared is 4, 14 squared is 196, right? This is 14 because it's 8 minus a -6. So that equals 200. And so the answer turns out to be 10 times the square root of 2 when you simplify the square root of 200.